Okay, let's get started. This is what we did last week. We manufactured two products, and we considered the constraints and budgets for each product. We also considered the profit by selling each product, right? And then we listed this given information in Excel, and we created these two cells to represent decision variables. We also created this yellow cell to represent objective function, right? If you double click on the yellow cell, you can see we built up an objective function inside. And then we set up the solver at the end. If you click data and then click solver, you should be able to see which cell is the objective cell, which one is the decision cells. And don't forget to set up the constraints, because constraints is the most important key feature of linear programming or optimization analysis, right? This is what we did last week. Okay, so last week when we set up solver at the end, I asked you to create an answer report and a sensitivity report. Let's talk about these two reports today. Let's talk about the answer report. What is the purpose of answer report? Basically, it's organize your analysis in a well-structured manner. In your Excel cell, you can find a cell like A1 to represent objective cell. In my analysis, I could use a cell B2 to represent objective variable, right? We have different formats, but no matter what, answer report will organize your analysis in a structured way. It shows you what is the value for objective cell, what are the values for decision cells, right? As you can see here. What is the value for objective cell? It's under objective cell area. As you can see here, $3,950, right? What is the values for each decision cell? It's under variable cells. For jackets, in order to reach 3,950, we need to manufacture 300 jackets and 100 parka, right? This is what we saw in our analysis, right? It's here. In our spreadsheet, we saw that. In addition to that, we have very important information. It's called the constraints. Right? Constraints. This report shows you two important information. One, the status of your constraint. For each constraint, you could have two possible statuses. One is binding, another one is not binding. What does binding status tell you? It tells you that you have exhausted all the resources available for that constraint. What about not binding status tell you? You haven't exhausted some resources for that constraint. So according to what I just tell you, for the first constraint, fabric, what is it? Not binding, meaning that, okay, after manufacture 300 jackets and 100 parkas, we still have some fabrics left. How many left? This is the second information, important information we can see from this area, 200. This is what the slack value tells you. How many resources you still have for that constraint. Any question about this? Okay, so not binding, right? The constraint below, not binding machine time constraint. What is the status? Binding. Binding means you have exhausted all available resources for that constraint. If you have used all the resources, How many resources do you have? Do you still have? Zero. Yes, zero. You have used all the resources. That's why you should know that for every binding constraint, as long as you see binding status for that constraint, the slack value for that constraint should be zero. Very good. Zero. Remember that. Right? Do you remember what the manager asked us? Second question. She said, first question, she wants us to determine how to maximize profit. We need to figure out how many different types of products we need to manufacture. What is best profit we can reach? That's the first information we need to answer, right? The second question, she wants us to understand the impact of each production resource has on the overall profit. Meaning that we are facing constraints, we should be able to interpret each constraint, the status, and the slack value. This is how you interpret the answer report. Right? Overall, the answer report has an overall purpose. The purpose is to organize your analysis in a structured manner. Right? As you can see here, in this example, this is the raw data I analyzed, right? But it's not organized. You could put the value in one cell, I could put the value in another cell. That's why we need to structure the analysis. This is the overall purpose of the answer report. Inside of the answer report, we can analyze so much information. Status of the constraint, how many resources we still have. And of course, you can see what is the best result you can reach? What are the values of the decision variables? All good? Very good. So if you are all good, let's talk about the second report. It's also very important. All information is important, right? Sensitivity analysis. Sensitivity analysis gives you two pieces of information as well. First, a variable cells. Second, constraint analysis. You can reach the best goal, right? That's what we saw in the answer report. Now we need to further analyze the decision variables and each constraints. In the variable cells, you can see the final value. Are they as same as the answer report? Yes. Yes. 300 jackets, 100 parkas, right? Right? 300 jackets, 100 parkas. As same as answer report. But why we need to repeat this answer again? Here is the reason. In addition to the final values, we have a coefficient, objective coefficient. We also have a allowable increase and allowable decrease. What does objective coefficient tell us? It tells us the coefficient of each product. Do you remember we said that we can get $9 as a profit by selling a jacket, right? 12.5 as a profit by selling a parka. That's exactly what the value that, right? Let me zoom in a little bit. $9 as a profit by selling a jacket, 2.5 as a profit by selling a parka. That's called the coefficient of the decision variables. That's the value you should multiply with the decision variables. It's given. In optimization analysis, we call these two values parameters. Do you remember last week I said ignore parameters, right? Here we need to pay attention to them. They are called parameters. Those are the values you should multiply each decision variable. Later in this semester, I will tell you how we get parameters. But at this moment, you should remember that parameters are the values you should multiply your decision variables. $9 as a profit by selling a jacket, 12.5 as a profit by selling a parka. Those are called decision coefficient, objective coefficient. Another name for these two values are called parameters. Parameters. Right? And of course, 300 and 100 is the value we calculate.
My force is 13.5. Why?
You typed it wrong. You need to check your analysis.
It's the same.
So all the answers should be the same. Yeah. You don't get 12.5. Check your Excel file. You type the answer, you type the value incorrectly.
No, my profit is same 3950.
No. If you switch back to spreadsheet, make sure the value is 12.5.
12.5.
12.5, right? Your analysis is incorrect overall. We need to talk about that during the break. If you get different answer, your analysis is incorrect. Any other question? This is what we call the parameters, right? Oh, by the way, in optimization analysis, for the same value, we could have different names. Why is that? It's a very interesting history story. Because optimization analysis is very important, both computer science discipline and analytics discipline, like data science discipline, do the same research on the same topic. So that's why we give different terms to the same value. You need to remember both, of course, right? For example, here, it's called in the sensitivity report. For $9 and $12.5, we call these values objective coefficients, right? That is the name given by computer science discipline. But as a business analytics field, we call these values parameters. We are talking about the same thing. Different names, because it's so important, right? After you study BUSA 542, after you see more applications of optimization analysis, you will understand how Google Maps, Apple Maps work by using optimization analysis. Right? I feel like I'm a salesperson, right? I'm getting you interested and selling you more. But this is just what we do. And all of these amazing technologies are based on fundamental disciplines like us, like optimization analysis, right? Like mathematical modeling. Okay. So this is what we talk about. And then we have allowable increase and allowable decrease. What does these values tell us? They tell us in which range your objective coefficients can change so that you can keep the current decision variable values to reach the best result. Let me give you an example. So we said we can get $9 as a profit by selling a jacket, right? Allowable increase value is 0.375. Allowable decrease is 0.67, as you can see in the report. So what does this mean? That means, okay, your current profit is $9, but what if you improved your business process? You can get more profit by selling jacket. So the current best result, as you can see, is 3,950. right? And you need to sell 300 jackets. But for some reason, you improved your profits of each jacket, right? This range, these two values tell you in which range the objective coefficient can change so that you still manufacture 300 jackets, you still reach $3,950 at the best profit. You don't need to change, right? This is what this range tell you. So allowable increase means you can add 0.375 on top of your current $9. That will be
9.375.
that will be $9.375, right? Allowable increase, decrease, $9 minus this decreased value. So if the profit of selling each jacket changes in this range between 8.33 and 9.37, you still manufacture 300 jackets. You still reach the best profit, $3,950. This is what allowable increase and allowable decrease tell everyone. And this is called optimal region. Let me introduce these terms to you first, and then I saw questions. I will answer your questions later. This is called optimal region. Another term of an optimal region is range of optimality. They refer to the same thing. Questions? Lady first? Okay.
I wanted to find out, so for the optimal region, do both need to change at the same time, or you can change one of the other?
Sometimes you did a poor job, so your profitability of each product decreases. And 8.33 is the limit you can decrease to, right? If you did a worse job, if the profit is $8 per jacket, then your current analysis will be overturned. You have to do a new analysis. If the profit by selling one jacket is between 8.33 and 9.75, you can hold your current analysis. You don't need to change a thing. This is what optimal region tells.
This report allow you to increase the profit to 9.375.
Yes.
How come the profit is 3,950? It will not increase?
It will increase. That's a very good question. It will increase. So you will still use a 300 to multiply 9.375. Very good point.
Increase.
Yes. Yeah. The profit will change. That means you still manufacture 300 jackets.
You can increase the price of the.
You can change the profit according to the new profit you get. Very good question. Yes. This just means the decision variable values do not need to be changed. Yes. But when you calculate the final total, you will use the new coefficient, 9.375, to multiply 300. So your total profit will change. Yeah. Right? All good? Okay. What about other classmates? Good question. Very good question. Because every time when we do analysis, it will take a lot of time and effort, right? So this range tells you in which range your coefficient changes, you don't have to do the analysis again. We are dealing with a small data set, right? But if you work for like a McKinsey, like PwC, those consulting firms, when you analyze this company, you will deal with a lot of different sales, different decision variables. So every time when you do analysis, it takes you time and effort. We want to see in which range we don't have to change our current analysis. Very good questions. Okay. And then we have a constraint area, right? Constraint. First, you see something called a shadow price. Shadow price. This value tells you how much the objective variable value will change if you have a one additional resource to put into that constraint. Let me repeat. The shadow price tells you how much the objective variable will change if you have one additional resource to put into that constraint. Let me show you an example. Let's say the first one, 0. 0. 0 in this case means, okay, the first constraint shows you fabric, right? 0 means if I'm able to give the laborers one additional feet of fabric, how much my total profit will change? 0 means doesn't change. Why? Why?
More than that.
No.
Because
This, go ahead.
because you're not giving any fabric to the employees, so how the productivity would change.
This relates to the answer report. What do we see about the answer report about the first constraint? It's not binding. Very good. Very good. Very good. I wish I can hear the aha moments if I teach my online class. I cannot hear them. Right? They usually don't put their face on. No sound, no face. Sounds like I'm the only one in the universe talking. Very good, Sharon. Very good. Because it's not binding. So it doesn't matter if you buy more stuff. You haven't used all the resources yet. The problem that you cannot make more profit is not the first constraint. You still have resources for the first constraint. The problem is other constraints. For example, second constraint. 4. What does this mean? Again, going back to the definition I just give you. Shadow price shows the value. The objective variable will change if you have one more additional resource to put into that constraint. What does this mean? That means if the second constraint is about machine time, right? Let's say you can buy more machine. If you give your team one more hours of machine time, your total profit will increase by $4. Exactly, $4. Yes. Why the second constraint can increase your profit? Because if you go back to the answer report, what is the status of the second constraint? Binding. Binding means you have used all available machine time. No more time, no more time. Machine time, right? That's why this is the bottleneck of your business process. That's why the shadow price shows you that if you can give your team more machine, they should be able to increase your profit. Are we all good? So, okay, so the next one is allowable decrease and allowable increase. Let's use the second constraint as the example. Allowable increase, allowable decrease. This shows you in which range your constraint value, the RHS value changes. So the current shadow price does not change. Fam, you good? Okay. As I told you, RHS value shows the budget limit. Sometimes upper limit, sometimes lower limit. In this case, 650 is the upper limit for the second constraint, right? No matter how many more you want to sell, 650 just limit your capability, limit your business process. So the RHS value for the second constraint is 650. And allowable increase, allowable decrease shows you how 650 changes so that the current shadow price does not change. You can calculate, right? Okay, so let's find the cell. Let's do this. Allowable increase for 650 will be 650, or you can use cell reference. This cell plus allowable increase, right? Okay. Allowable decrease, this value minus 12.5. What does this mean? This means if the RHS value for the second constraint changes from 666 to 638, the shadow price for the second constraint remains 4. And we call this range feasible region. Feasible region. Of course, we have the second terminology. It's called a range of feasibility. They refer to the same thing. Are we all good? Okay, if all good, my job is done for today. Yeah. This is what I want to focus on today. The two regions, right? What they represent. And of course, shadow price. And between shadow price, you can find out which constraint you should address in priority. Let's say we cannot, question?
The visible region and range of visibility again.
What?
The visible region. How you got that? Yeah, the explanation on that. I just need you to recap.
Feasible region is about RHS value. Do you still remember RHS value? They show the limit, no matter it's the lower limit or upper limits, right? They show the limit. So feasible region shows in which range your RHS value changes so that the shadow price remains. Good question. Continue my topic. I told you that between constraints, if you only have limited money, you can choose which constraint you should address in priority. Which constraint? Whichever gives you the largest shadow price. So let's say I only have $1 more. Should I buy more machine or should I hire more employees? More machine, why? Because the shadow price for machine time is 4. If I hire more employee, I can only get $1.5 more. So if I only have $1 more, I should address machine time in priority.